Okay. All right, so goal for this section is to solve. So by the time you're done, you should be able to solve and graph compound inequalities. And we'll talk about that in a little bit. So you should be able to solve and graph compound inequalities. There are two types of compound inequality, but before I tell you what they are, I gotta tell you what is a compound inequality. Compound inequality. Anybody have an idea what that could be? What is a compound inequality? No? Nobody wants to say anything? Joshua, do you know what is a compound inequality?
Did we take notes over this?
Mm-hmm.
I have it in my notes.
All right, I'll tell you. Ready? It is two inequalities joined by and or.
Oh.
Okay? And it is two graphed on one number line. Okay? So they're the two types. And compound inequality and an or compound inequality.
How come you didn't just put the quotation mark on the first one?
It's and
You can put like
and the other one is an or. There's an and compound inequality and an or compound inequality.
Oh, okay.
So the word or
Yeah, I
means
got
either
confused
or.
with the two
Yeah,
ors.
yeah. Sorry about that. Maybe I should have put or and.
No, you're fine.
No? Okay. I don't know. Okay. So let's start with an example of a compound. So this is example number 1. It's going to say write a compound inequality. So write a compound inequality for the situation, and then it says to graph. Okay. So here's the first one. All real numbers that are at least -1 and at most 3. So I want to write a compound inequality that would represent
What's that word right there?
at most.
Write a up
Oh, right.
at the beginning.
Write
That
a
looks like
compound inequality and graph.
Oh. I'm stupid. I read that wrong. I thought your D looks like a C and an L.
Oh,
And I was confused.
it does.
I was like,
It's not you. It's my handwriting. So this is what this would look like. First of all, this gave me a hint that this is an and compound because they use the word and. Okay? So I want all numbers that are at least -1 and at most 3. So what is the minimum of all these? -1 and the maximum?
3.
3. So the numbers have to be between them, right? So first of all, we're going to define our variable first to have, right? To let x be all real numbers. And if you notice, what I would do, the easiest thing I would do is actually graph it first. So here's -1, here's 3. Okay. At least, does it mean to include -1?
No.
At least, can
Oh, yeah,
it be
yeah.
-1? right? It could be -1. So I'm going to make a closed circle to include -1. And what else, which way should I shade?
To the
Left.
right.
To the right, right? Because at least means -1 is the minimum and everything else has to be greater than, right? So we're going to go do this, okay? So all the way over here. But it also has to be at most 3. So open a closed circle at 3.
Close.
Close, but it could be 3. Now, could it be more than 3?
No.
No, so I got to shade to the left. So this is the graph, right? This is the graph that represents all this. Now I'm going to write my compound inequality. I kind of did it backwards, but it's easier to see what my numbers are going to be before I could write it. I think graphing is a little bit easier, don't you think? Okay, so now all the numbers right here, those are my x's. Those are all real numbers. That is at least -1 and at most 3. So I'm going to rewrite this here, x. And you know that x is greater than or equal to, so greater than or equal to -1. And x is less than or equal to 3. This is an and compound inequality. And when they graph, they point toward each other. Okay? And it is where they overlap. That's why it's an and, because it has to meet both conditions. It has to be at least -1 and at most 3. So, and this is what an and compound inequality looks like. Okay? This is an and. X is between -1 and 3.
Alright.
Yes.
So I'm guessing or is like when they go both the opposite direction.
Yes.
What's it called when they're both going? Wait. Yeah. What's it called when they're both going in one direction?
That is wrong. That's a mistake.
Oh.
Okay. So this is an and. Any question with an and?
No.
You graph toward each other, and you write. This is what an and compound looks like, where the x is between the smallest number to the biggest number. X has to be between there. Okay, this is an and. Okay, any question? No question? Okay, so then let me give you one for or. Ready? All real numbers. Oops. That are less than 0, or that is a 0, or greater than 3. All real numbers that are less than 0 or greater than 3. So maybe I should put that 0 right here. It's kind of confusing with that by itself. Okay. So same thing again. We're going to use the same define. We're going to use x to represent all real numbers for this one as well. Is that okay? Shall we graph it first? Yeah. Here's 0. Here's 3. Remember, number line, it has to be in numerical order, least to greatest, right? All right, let's do this one first. Less than 0.
Open.
Open, and right or left?
Left.
Left, because it's less. Okay? Or greater than 3. Open or closed? Open, and right or left? To the right, because it's greater. This one, arrows are pointing in the opposite direction. And it's because it's an or. Ors will always graph this way. And when you write your inequality, here's my x. So x is less than 0. Or you actually use the or in your compound inequality. And then this is, here's my x. X is greater than 3. So this is an or. Okay? Ors, use the word or, and you write them separately Where and, you use one x, and x is between the smaller and the bigger number. That's the difference between and or compound inequality. Any questions so far? So you guys know the difference? So if your arrows are pointing out, it's an or. If arrows are pointing in, it's an and. Okay? Any questions? So you know how to take the word problems and write a compound inequality and graph them? And do you see how graphing it first makes it easier to write your compound inequality? Right? I recommend that, but you don't have to do that. All right, now can we solve? Can we solve? Ready for the next example, number 2? I don't know. Are you? You probably want to grab another piece of paper. All right, we're going to solve compound inequality. Now, the book has it separated into 2 separate examples. I'm going to do A and B. Is that okay if I did A and B? Okay. All right, so we're going to be solving. So the first one is this. This is a solving an and. So here's A. This is an and compound inequality. It's going to say solve. 5 is greater than 5 minus x, which is greater than 2. Okay? We're going to solve. Now, the way the book does it, it separates this into 2 separate inequalities. I like to do it all at once. Would you prefer to separate this into 2 separate ones and bring it back together, or do you want to do it all at once? Do it all at once? Okay, so this time, instead of 1 dash line, we're going to do 2 dash lines. I have an inequality here. I have an inequality there. You're going to do exactly what we did by solving for x, right? So we want to get this x by itself. So just looking at here, what do I have to do to get rid of that 5? Subtract 5, right? Because I want to get x by itself, I got to subtract 5, so I'm going to subtract 5. But instead of just subtracting 5 to one side, you're going to do it to both sides of the dash line. So you're going to subtract 5 here, subtract 5 here, and subtract 5 here. You got to remember to do that if you're going to do this all at once.
So make sure you have negative x.
So this cancels out. 0 minus x is negative 1x. I'm going to put that 1 there because if there's no number, it's always 1. If there's a negative there, it's negative 1. What's 5 minus 5? 0. And then 2 minus 5? Negative 3. Do I have to flip the inequality when I bring this down? I just subtracted, right? I didn't divide yet, so I'm going to bring this back down as is. Now we're dividing by negative 1. So now after we divide, but then we have to flip. After we divide. So to get x by itself, this is multiplying. So to get rid of this, you got to divide by negative 1. But if you divide it here, you have to divide it here and here. Okay? What's 0 divided by negative 1? 0. Negative 1 divided by negative 1 is 1. 1 times x is x. And what's negative 3 divided by negative 1? 3. Because 2 negative makes it a positive. And because we divide it by a negative number, we must flip the inequality. This is an and. So now when I graph it, am I going too fast?
No.
Okay. Here's 0 and 3. Let's graph this one first. When you read it from the variable size, it says x is greater than 0. So open or close at 0.
Open.
Open. And which side is greater? 3 side? Right or left? Right.
Wait for which one?
This one. X is greater than 0. So this side is greater than 0 than this side, right? Here's negative 1 here. Here's 1 here. 1 is greater than negative 1. So that's the side we shade. Now open or close at 3. Open. And this one says x is less than 3. So which side, right or left? To the left. So if you notice, they're both pointing toward each other. This is an and you know you grabbed it correctly, and you solved it correctly. Okay? Any questions with this? Is this difficult? No, not yet? All right, let's do an or. Here's an or. Now, or, they will give it to you separately with the or between them. Ready? So it's going to say solve, and it says 3x plus 2 is less than negative 7, or, and they always use the word or, and negative 4x plus 5 is less than 1. So this one, unlike the and, you do them separately, and you keep the word or, in your answer. Okay? And how should this graph look like?
Should go this way.
Yeah, it should be going in the opposite direction, right? One's going to the left, one's going to the right, because it's an or. Ors always go point away from each other. All right, so let's do this one first. We draw that dashed line. Right? What do we do first?
You get 2, like, you subtract 2.
Wait, do we not put dash line on the other side?
No, we're going to do one inequality at a time. These we do separately. Or so you do it separately, and you can do it together. So this one minus 2 minus 2. So don't worry about this. I'm going to cover this side up. I'm going to cover this up, so we're not going to do that yet. We're just going to do this one first, right? So then this will be 3x is less than negative 9 and divided by 3. Do I flip my inequality? No, because it's positive 3, not negative. Even though this is negative, this is positive. So x is less than negative 3. Okay, so you do that one. Am I going too fast?
No.
Okay, am I going too slow?
No.
I could do fast. No? Okay. Now we did this one, so now we come over here and we do this one. Okay, so we cover this side up now. We're going to come over here, draw that line. What do we do? Subtract 5, subtract 5. And then we do negative 4x is less than negative 4, right? Divide by negative 4, divide by negative 4. And because we divided by a negative 4, we got to flip the inequality. So this becomes x is greater than, what's negative 4 divided by negative 4? 1. Okay, so if you noticed, this is an or, so box in your answer. Now let's graph. You ready? Number line. Here's negative 3. Here's 1. Let's graph this one first. Open or closed?
Open.
Right or left? Left. And then this one, open. And you know for sure that you did it correctly because they're pointing opposite each other, and there's that word or. Any questions with this? So fairly easy. Okay, I think I'm gonna save the hardest one for tomorrow. Is that okay? Okay, so we'll do